बटन दाबायचं. हे लाल बटन दाबले की रेकॉर्डिंग सुरू झाली. हां, 10 मिनिटाचं रेकॉर्डिंग बंद होईल. परत ते लाल बटन दाबायचं. 9व्या मिनिटात ते लाल बटन दाबायचं. इथं बंद करून परत चालू करायचं. ठीक आहे. Okay, folks. So in the last class we were looking at autocorrelation. Okay, what is autocorrelation? Just take a brief review. What is autocorrelation? If the error terms are correlated, right? What is first order autocorrelation? If the error term in this period is correlated only with the error term in the past period, which is called an AR1 model, autoregressive of order 1 or autocorrelation of order 1. What is autocorrelation of order 2? AT depends on ET minus 1 and ET minus 2. That is autocorrelation of order 2. So in general you can have autocorrelation of order P. But we are going to think of autocorrelation of order 1 in this simple class. So in the last class we said, let Yt is equal to alpha plus beta xt plus vt, et, right? And et is phi et minus 1 plus vt. Vt is a normally distributed random error term which is uncorrelated with its own past and present values. So we will say Vt is normally distributed with mean V, variance sigma square V, and covariance so what this means is that covariance of Vt and Vt minus j is 0 for all j not equal to 0. So if j is equal to 1, then we talk about covariance Vt, Vt minus 1. If j is equal to minus 1, we think of covariance Vt, Vt plus 1. Right? So Vt is past correlated, uncorrelated, past and future values. Right? So this is our model. Then what did we study in the last class? We said that if this happens, the t values are not correct. Sigma square upon summation, sigma square e upon summation, xi square is not the correct formula for the variance of beta hat. Right? So we said let's go first the FGLS route, the feasible generalized least square root. How do you go by the FGLS route? For the FGLS route we said what you first do is multiply Yt by phi. But first think of Yt minus 1. So your Yt minus 1 plus alpha plus beta xt minus 1 plus Et minus 1. Multiply this by phi. Right? So this is yeah. Then what's the next step? Subtract this from this. So you get Yt minus 5 Yt minus 1 is equal to, so it will alpha into 1 minus phi plus beta into xt minus phi xt minus 1 plus vt. And Vt is non-autocorrelated. Right? Vt is by definition non-autocorrelated. So if you think of this whole thing as y star t, if you think of this whole thing as alpha star is equal to alpha star plus beta, if you think of this as x star t, right? X star t plus vt, then you can estimate beta from here, and the variance of beta hat will be sigma square v upon summation x star t square. Right? Actually because there is an intercept, it will be x star minus x star t minus x star bar square. Right? Sure? So you can then take t-test, hypothesis and all that. Tests of hypothesis can be taken for the null hypothesis, beta is equal to 0, using this formula rather than the formula sigma square E upon summation xi minus x bar square. You see the two formulae are different. This is the correct formula, right? This is a GLS. These are generalized least squares in a simple context. But obviously this is not feasible unless you know the value of phi, because the whole idea involves multiplying yt minus 1 and xt minus 1 and et minus 1 by phi. So unless you know phi, you can't do it, right? So what you essentially do is you need to find phi. How did we say we find phi? First, yes, you regress yt on xt. Then get the errors e hat t. Then regress e hat t on e hat t minus 1 without a constant. Right? Okay? And then you get phi hat. You get an estimate of phi hat. Use that estimate of phi hat to carry this procedure out. Okay? This is called the feasible GLS in the context of first order autocorrelation. Right? Okay, if you obviously have a different order of autocorrelation, then the method will change. Okay? But here we are concerned with the first order autocorrelation. Now the important question is, suppose you have data and you are interested in finding out whether there is autocorrelation. Okay? If there is autocorrelation in that data. How does one find that out? Okay. So first let's look at some simple methods of some simple AR1 processes, okay, which will anyway be useful to us. And then we also, in that context, because we now have some time, we'll also be able to understand more clearly her question about why the absolute value of phi should be less than 1.